Okay, I want to pick up where we left off yesterday. And in your particular class, that means I want to talk about these boxes. And all these boxes are kind of doing is they're just kind of summarizing what we did on example 2 yesterday. So, realize there, that first box says odd roots. So when I talk about odd roots, which roots did we do that were odd yesterday? Odd roots were when we talked about cube roots and fifth roots, right? And so this is what happens when you're doing odd roots, whether it be cube roots, fifth roots. I mean, technically we could go seventh roots, ninth roots, anything past that. We don't usually. But when we talk about cube roots and fifth roots, what always happened? Anytime we took a cube root or a fifth root, we had how many answers? We always just had one answer, right? Like what we had up here. And what about the sign on that answer? If my original problem was positive, the cube root or fifth root was positive. If my original problem was negative, my cube root or fifth root answer was negative. And so just to kind of summarize, odd roots, one real root, so just one answer, and the sign always matches the base or the original problem. So if you're doing the square root of the cube root of a positive, your answer is positive. Fifth root of a negative, your answer is negative. So that's kind of what the summary about odd roots means. Now, even roots. Even roots we worked on yesterday were what? Square roots and fourth roots? Oops. So if we talk about square roots and fourth roots here, the idea on a square root or a fourth root, can I get zoomed out enough we can see a couple? If it was the square root or the fourth root of a positive number, if that base is positive, what had to happen? When we took the square root or fourth root of a positive number, we got how many answers? We got 2. We always had 2 real solutions, the positive and the negative. So when there's a positive base, 2 real solutions, plus or minus. What if there's a negative base? If there's a negative base, could we do a square root or fourth root of a negative number? And we could not, and so then there were no real roots. So that's just kind of a summary as we go forward that, okay, if it's cube roots, there's always going to be one answer. Just use the sign of the original problem. If it's square roots, fourth roots, 2 answers usually, plus or minus, unless it's a negative, and then we have to say none. Okay? I think those boxes would have made a little bit more sense yesterday if in this class we'd been able to talk about them at the end of class yesterday, but since we ran out of time, we didn't get to. But again, they're just good summary boxes, I feel like. So make sure you have the information you want from those. And then I'm ready to talk about example 3 when you guys are. You are not ready. Are you still working on... Okay, I can, at the end of class, you want me to take a picture of today's notes at the end of class and send it to you via email? Will that help? I mean, I still want you following along and getting what you can, but that way you can get some of the pieces that you're missing. Okay? This is Mallory, right? All right, not Mallory, Maggie. So yeah, get what you can, and then I will email those to you today if that will help, okay? You're welcome. Okay, example 3. Notice the directions just say, what is each real number root? Now, as we look at the difference, basically we're doing the same thing we talked about yesterday, but there is one slight difference that I really need to mention. And the difference is made because notice On the problems we did yesterday, it just said what are all the blank roots, and it gave me a list of numbers, and we gave answers. Down here, it's asking still for roots, but notice all of these problems are being asked given radicals. There's one slight difference when we use the radical sign. Now, it only happens with our even roots, our square roots and fourth roots. But that we'll have to talk about that when we get there. Otherwise, for the most part, this is the same thing we did yesterday. So I'm going to zoom in on 3a here. What is each real number root? And a says the cube root of -8. This is one you should be able to somewhat come up with. Cube root of -8. We talked about all the pieces yesterday. -2. Because the cube root of 8 is 2. Cube root of a negative is always a negative. So no difference than what we did yesterday in that case. Yes. And you have a TI 83 or 84, don't you? Mm-hmm. So it'll be a little bit different, but yes, I can help you with that later. Yep, remind me. Okay, B. Square root of 4/100. He says 0.2. Here's my thought. If the decimal part is stressing you out, look at the fact there's a 4, yes? What's the square root of 4? 2. So we know that our answer has a 2 in it. Now, the calculator can help you out, but being able to use some math logic is helpful too. How many numbers are after the decimal in this problem? There's 2 numbers after the decimal. What kind of root is this? This is a square root. Square root is represented by 2. What's 2 divided by 2? 1. And so what that means is there's going to be 1 decimal place in my answer. So if my answer has a 2 in it, we need 1 decimal place. We're going to say 0.2. Now, if this was like the problems we did yesterday, and I asked for all the real roots of 0.4, what would you have to say here? We would have to say positive and negative if it asked for all the real roots. Now there's a catch here. And the catch is, when they ask for all the real roots, when we're in equation setting, yes, we use plus and minus. Because it's a radical sign. When they give the radical sign, they only want the positive root. They don't want plus or minus. They only want the positive root. If they wanted a negative root, they would put a negative out front of the radical, and that would tell you to give the negative root. But because it's a radical sign, the radical sign generally only wants the positive root. And I'm going to write a note down here so that you have it. And my note's going to say radical sign represents only the positive root. And I'm going to comment then in an even root. Okay, so I did not put plus or minus there because of the radical sign. They only want the positive solution. So radical sign represents only the positive root, and that's when we're talking about an even root situation. So square roots, fourth roots, so on and so forth. Okay, copy down the information you want, and then start looking at C. C is the fourth root of -1. Thoughts on the fourth root of -1? What? It says no solution. Why would it be no solution? Yeah. Okay, yeah. Are there 4 of the same number they're going to multiply to be a negative? And the answer is no, because 4 positives multiply to be a positive. 4 negatives multiply to be a positive as well. So because we're trying to do an even root of a negative number, there are no real roots. And D, square root of -2 squared. What? 2? Why 2? Okay. So -2 squared, if we start under the radical, which you should, because it's kind of like parentheses. You start in the parentheses, in the radical. -2 squared is 4. Well, then when you turn that around, what's the square root of 4? 2. And again, also keep in mind, it's a radical, so they want a positive result. Okay, get what you need from there, flip to the back side. On the back side, it says at the top the nth root of nth powers. And in my mind, the big thing on the back side we have to work out is how do we do square roots, cube roots, fourth roots, fifth roots with variables and exponents. You guys can tell me square root of 25, cube root of 8. You guys can do the numbers, and the calculator can help you with the numbers. But the calculator can't help you with the variables and the exponents. And so that's where we have to know what our rules are. Now, generally speaking, it's a pretty easy thing to figure out. The one catch we have to watch out for is when they're variables, we have to think about absolute value. And the idea there is, if it's a cube root, a fifth root, we can have negatives in our radical. We can have negatives in our solution. However, if it's an even root, so if this n is even, then we have to consider absolute value because we don't know what x is. We don't know what y is. But the key is, if it's a square root or a fourth root or some kind of even root, it has to be a positive answer. And so we sometimes have to use absolute value to ensure it's a positive answer. Now, I'm going to walk you through exactly how to figure that out. So I won't leave you hanging there. Let's go ahead to example 4a, and we'll talk it through. Let's start with the basics, though. What is a simpler form of each radical expression? So square root of 16x to the 8th. Get the easy part out of the way. Square root of 16. 4, right? Square root of 16 is 4. Square root of x to the 8th. So what times itself gives me x to the 8th? So x to the what power times itself gives me x to the 8th. Good news is there is a shortcut, so it's really not that challenging to figure out, I promise. But when we look at x to the 8th, x to what power times itself gives us x to the 8th. What do you do when you're multiplying and there's exponents involved? Do you actually multiply the exponents? If it's x to some power times x to some power. You keep the base the same and you do what with the exponents? You add them. So, here's a better way to ask it. What plus what is 8? 4. Now, my shortcut, so I don't have to think that way every time. If this is a square root, what's the invisible number here? It's what? A 2, right? What do you know about 8 and 2? 8 divided by 2 is what? X to the 4th. So my shortcut recommendation when you're trying to do radicals that involve variables, okay, take whatever your power is, so here it was x to the 8th, and divide it by whatever my index is. So whether it be a square root, a cube root, a fourth root, so on and so forth. So in this case, 8 divided by 2 makes it x to the 4th. So square root of 16 is 4. Square root of x to the 8th is x to the 4th. Now, here's a trick that we have to talk about every problem. Do I need to consider absolute value? And here's how I decide. The index of 2, is 2 even or odd? 2 is even. Anytime my root is even, we need to consider absolute value. And so when I say we need to consider absolute value, for me as a teacher, when we're going through the work, I'm going to put absolute value on there temporarily. When I say consider it, we're going to discuss it. Do we really need that absolute value, or is it okay without it? What does absolute value do to something? The short of it is it makes it positive, right? So, right now, I have a 4 inside the absolute value. Does that 4 need the absolute value to make it positive? No, because 4 is already what? 4 is already positive. So does 4 need to be in the absolute value? And the answer is no. Okay, so if you already have a positive whole number, that doesn't need to go in absolute value. Then you have to look at your variable. Does x to the 4th need absolute value to make sure it's positive? Now, do we know what x is? We don't know what x is, do we? X could be positive or x could be negative. So play with the idea that x is negative. What happens when you raise any number to the 4th power? Anything raised to the 4th power is automatically positive. So do I need absolute value to make x to the 4th positive? No, I don't care what x is. If I raise something to an even power, it's automatically going to be positive. So in this particular problem, we considered it, we talked about it, but we actually don't need any absolute value on any final answer here. Now, we're going to talk about this in every problem here. So by the end, I think you'll have it under control. There are some problems in MathXL where you have to put absolute value. Okay, so beware, be prepared, because you will get them wrong if you don't put the absolute value. Okay, let's try B. Don't think absolute value or anything right now. Just think, how do I do the cube root of a to the 6th, b to the 9th? So how did I do a square root? I took my power and divided by 2. How am I going to do a cube root? Take my powers and divide by 3. So the cube root of a to the 6th means I'm going to do 6 divided by 3. The cube root of b to the 9th means I'm going to do 9 divided by 3. What do those powers become when I simplify? Yeah. A to the 2nd, b to the 3rd. Now, before I circle my answer and move on, do I need to consider absolute value? And in order to answer that question, look at your index, your radical. This is a cube root. What do you know about a 3, a cube root? 3 is odd. Are we allowed negatives within a cube root, within an odd root? Yeah. On the front side of the notes, we did cube root of -8 and got -2. It's okay to have negatives. So do I need absolute value? No. Anytime it's an odd root, you don't even have to consider absolute value. So because that is odd, no absolute value. We only have to consider absolute value if it's an even root. Okay? So and again, I'm trying to make it obvious there that, okay, I didn't do absolute value because that number is odd. Okay, see you when you're ready. 4th root of x to the 8th, y to the 12th. I would like to think we know how to do the first part here. How do we do the 4th root of x to the 8th, y to the 12th? Okay, divide those powers by 4, since it's a 4th root. So I'm going to have to do x to the 8 divided by 4 and y to the 12 divided by 4. What do those values become? X to the 2nd, y to the 3rd. And before I finish my answer, do I need to consider absolute value? What kind of root was this? A 4th root. And what do you know about 4? 4 is even. Because it's an even root, guess what? I've got to consider absolute value. It's an even root. I'm not allowed a negative answer. Now, like the first one we did earlier, think about each part. Does x squared need absolute value to make it positive? Anytime you square something, it's automatically going to be positive, isn't it? So x squared does not need absolute value, because when you square something, we get a positive. Period. End of statement. Does y cubed need absolute value to make sure it's positive? And think about it. What happens if y is negative? What happens when you raise a negative to an odd power like 3? 3 negatives multiply to be a negative. And because this is a 4th root, I'm not allowed a negative. So here's an example of that y to the 3rd has to stay in absolute value. Okay? Now you want my shortcut? If it's an even root, so like an even index, like 2 or 4, and you have an odd power in your answer, those are the ones that are going to need absolute value. Even powers will never need absolute value. So if it's an even root up here, but an odd power down here, that's when you need absolute value. Okay? Yes? What? Yes. Yeah, you should. Look down to 7th period at the very bottom. Okay, you guys ready for the second row? You got the gist? Square root of 81 x to the 4th. Okay, get the easy part out of the way. Square root of 81 is 9. How do I do square root of x to the 4th? Divide it by 2 because it's a square root, so it's an invisible 2 right there. And 4 divided by 2 is going to be x to the second. So I have 9x squared. Okay, what's my question to you? Yeah, do I need to consider absolute value? When have we considered absolute value in the past? When the root is even. A square root, is a square root even? Yeah, square root is even. And so, me considering absolute value is putting absolute value on my answer while we talk about it. Okay, does 9 need absolute value to make it positive? No, 9's already positive. No absolute value needed. Does x squared need absolute value to make it positive? No, because when you square something, a negative times a negative becomes a positive. So we considered absolute value, but good news is we don't need any. Okay, E. Cube root of a to the 12th, b to the 15th. What are you doing? Taking the powers of 12 and 15 and dividing them by 3. Because it's a cube root, dividing by 3. So when we divide by 3, these become a to the 4th, b to the 5th. Absolute value question. Do I need to consider absolute value? What kind of root is this? It's a cube root, which is odd. Are we allowed negatives? Yeah, you can have all the negatives you want with cube root. So we do not need absolute value. So final answer, a to the 4th, b to the 5th. And F when you're ready. Fourth root of x to the 12th, y to the 16th. How do I do a fourth root? Divide by 4. So we divide by 4. This becomes x to the 3rd, y to the 4th. Do we consider absolute value? This is a fourth root, and 4 is even. So because it's even, we need to talk absolute value.
You do the same thing as you did on C and like separate.
Yep. Yep. Look individually at parts. So look at x cubed. Does x cubed need absolute value to force it to be positive? It could. If x is negative, x cubed could be negative, and we don't want that. So x cubed has to go in absolute value. Now, I'm going to wait to finish my absolute value until we decide what we're doing with y. What about y to the 4th? Could y to the 4th be negative? No. Y to the 4th could never be negative because it's an even power. So that one will be outside the absolute value. So I'm going to write this as absolute value of x to the 3rd times y to the 4th. Okay? So I think the variables themselves are pretty easy. The catch will be watching out for absolute value. Okay? If I recall correctly, I don't feel like you see a ton of absolute value in homework, but you do see a little. So just be prepared and watch out. Okay? One last example, and then you guys can have a few minutes of work time. Example 5. It's your favorite. It's a word problem. What is step 1 on a word problem? What? I couldn't hear what you said. Okay, write everything out. I was waiting for someone to tell me to skip it. It's words, just skip it. Not my preference. Okay. Step 1, we read it. Okay. My step 1 is we actually sit and read the problem for a moment before just automatically skipping over it. So, let's read. Some teachers adjust test scores when a test is difficult. I don't usually. One teacher's formula for adjusting scores is A equals 10 square root of R, where A is the adjusted score, R is the raw score. If the raw scores on one test range from 36 to 90, what is the range of the adjusted scores? Okay, so what's the good news? What you see in this word problem? I think it's good news at least. There's what? You got a formula? That's always good news in my book. If they're going to provide me a formula and I don't have to try and come up with one, they're telling me A equals 10 square root of R. It says that, let's see, in there, A is the adjusted score, R is the raw score. What else do they give me? Raw scores on one test range from 36 to 90. What are those 36 and 90? They are what? Raw scores. So what are they going to go in place of? They are R values. And then what does it ask me to find? What is the range of adjusted scores? They're asking me to find A. Not a crazy difficult problem, I promise. So if it's A equals 10 square root of R, put in your first R value. A equals 10 square root of 36. You'll work that one, and you'll have to do the same thing again. A equals 10 square root of 90. What is the square root of 36? 6. 10 times 6? 60. So a raw score of 36 earns an adjusted score of 60. Okay, 10 square root of 90. What is the square root of 90? Anyone got the calculator answer? I went a little bit farther than 9.5. Yeah. I have written down 9.487, which I think is a rounded version. Okay, I went a couple of decimal places to get us started. So, now, what happens to 9.487 when you multiply by 10? What happens when you multiply something by 10? Yeah, 94.87, which 94.87 is approximately what? 95. So a raw score range of 36 to 90 is an adjusted score range of 60 to 95. So not crazy difficult in terms of how word problems go, by any means. Okay, your homework for tomorrow is to finish, or start and finish, lesson 6.1 in Math Excel. You have about 7 minutes till the bell. You can get a little bit of time done. These aren't like the iPads aren't like your computers. It took forever to log on. The iPads you could actually get on in a reasonable amount of time. So use these few minutes, I would suggest.